Welcome to the intro slash review slash clarification of our lab for mixtures and pure substances. So I'm going to briefly go through the background with you, sort of explain this little flow chart here, and then show you how I would go about getting started on the lab itself. But you should have basically this background and materials and start to procedures, your page with discussion questions 1 through 10, and then you've got this table here that we'll be filling in that's called categories of matter, and then you've got your matter examples sheet. So you'll need all those guys there, and let's get rolling. So basically this is looking at matter, or maybe more specifically would be how we can categorize matter. So you should be comfortable with this term. I mean, matter is basically anything that exists. If it's got some mass, or it's made up of some stuff, and it's got some volume, or it occupies some space, it's matter. So anything that exists is matter. Pretty general definition. But we're going to take it and just categorize examples of matter with this. So the basic way of categorizing it is to figure out if it's going to be a mixture, or if it's what's referred to as a pure substance. And it gets a little bit trickier because then we can break that down further. If it's a mixture, we could determine whether it was a homogeneous mixture or a heterogeneous mixture. And if it's a pure substance, we could determine whether it's an element or a compound. So ultimately, you kind of have to be able to take an example and put it into one of 4 categories of matter. That would be homogeneous, heterogeneous, elements, or compounds. And you might say, well, Cash just said there's only mixtures and pure substances. That's true, but each of those have their own little 2 subcategories there that we're responsible for. So let's take a peek at what a mixture is first. Basically, a mixture is going to be something that you could physically, and I say physically, not chemically, separate into its components or into its parts. And basically what determines whether it's going to be a homogeneous or a heterogeneous mixture is what's it look like. So think of it like this. If you've got a homogeneous mixture or heterogeneous mixture, those terms sound pretty familiar, but if you notice, you've got different prefixes. And that's what's going to tell us what means what. So a homogeneous prefix, the homogeneous mixture, that's going to be ones that are all the same. Homo as a prefix means same. So this would be something like milk, or a stick of butter, or black coffee. So what do I mean by that? If I'm drinking, I like black coffee. I drink a pot of black coffee a day. And when I pour a cup of black coffee, I expect the first sip to be the exact same stuff as the last sip. Now, sure, the temperature may change. If I'm not using my good Yeti mug, it could be colder at the bottom. But I know that it's going to be basically made up of the same stuff at the top or the bottom. Or like if I grab a gallon of milk and I'm making some cereal for breakfast for myself and the kitties, and it says it's homogenized on there, that's just saying, hey, look, this is the same all the way through. So if I grab a gallon of milk, I don't need to shake it or worry about there being different parts. Now you could make an argument, what if your milk's gone bad? What if it's spoiled? What if it's rotten milk? Well, sure, then that's a whole different thing. But just good milk on its own, that's going to be a homogeneous mixture. The air we breathe, it's a homogeneous mixture. And that's a good thing, right? We don't have to jump from a pocket of oxygen. Oh, wait, the oxygen caught on fire. Now we jump to the nitrogen and we hold our breath. Oh, boy, now we jump over to a pocket of carbon dioxide and we've got some problems. It's just all mixed up so evenly that you can't tell the difference from one sample to the next. So a heterogeneous mixture, that's going to be a little bit different. So think about if I took a sample of pond water. We go out with Mrs. Johns for an AP environmental lab, and we're going to take a sample of pond water. And I take a sample over here by the shoreline, and you get one that's way out real deep, and someone else dips around to the other side, and we all come back. I don't think you'd expect each of our samples to be exactly the same. Maybe I got little critters in mine and you've got some plant material in yours and someone else has a piece of floating leaf in another. They would all be a little bit different. Or if you like salad, right? I mean, if I make a nice garden salad, I don't expect every single forkful to have the exact same amount of the exact same stuff. I don't like tomatoes, so guess what I do? I pick them off. That's me physically separating them out. Well, what's the difference between a homogeneous and a heterogeneous mixture? You can usually see the different parts that make up a heterogeneous mixture. So if it is something that's not a mix, so we're like, why are we even talking about this? This is something that we're not going to be able to physically separate. Then there's a good chance that it would be what's referred to as a pure substance. So a pure substance, you can't separate it into smaller pieces or into its individual components by physical separation. Now, compounds, you might be able to like chemically separate. If you've got an element, you could break it down to just one atom of whatever the heck that is. So a pure substance is either going to be an element or a compound. The easiest way, I think, is if it's found on the periodic table of elements, then it is an element, which just basically means if I had a sample of gold and I were to cut it in half, and I cut that half in half, and I cut that half in half, and so on and so forth, I could get all the way until I've got just one single atom of gold. Now, you could break that atom up into smaller parts, but that's not unit one. You could get down to just one atom of something, it's an element. Compounds, these are going to be two or more atoms with chemical bonds. So you might have to use some means of chemical separation to break those up. But if you've got elements or an elemental symbol or a chemical formula, that's a real good chance that for what we're working at in this first unit, that it's going to be a compound. And the only way you could split that up would be by some sort of a chemical process. So I got this little flow chart here, and this is how I think about it. I get a sample, and I ask myself, all right, is it something that exists? And I have to say yes for just about everything, right? Because it's matter. Okay, is it something that I could physically break down into something? And if the answer is yes, I have to say, okay, well, is it so evenly distributed that every single sample size would be the exact same? That's not to say that, again, I couldn't separate them. Maybe I got to physically separate them out. So like if I go back to my black coffee, I know that there's coffee and water in there. I could boil off the water, or maybe I've got a real good filter and separate those two. But if I just have my black coffee and it's so evenly distributed throughout that I know that the top and the bottom and the middle or any sample size would be the same, it's homogeneous. If I'm like, no, there's definitely different parts there that I could physically separate. Like, the example I gave you earlier was like garden salad, or like, if I reached into, a random bag of candies, right? And I pull them out, I know that there's going to be different types of candies that are there. Well, if I can like pick out the individual different parts physically, then it's heterogeneous. So maybe we're thinking, no, this has nothing to do with physical separation. This is something that is going to be different. It's going to be a pure substance. So our pure substances, again, those are the ones that you can't separate into solid substances by just some sort of a physical separation, right? So then I can the way I think of it is like, okay, well, is it something I could break down into a single atom? Which basically means, is it something that's found on the periodic table? The answer is yes, it's an element. If the answer is no, there's different atoms that are bonded, chemically bonded here. Well, then if there's different atoms that are chemically bonded there, then it's going to be a compound. So that's kind of like my process of elimination, is first determine which of these two it would be, and then figure out, okay, well then which of those or which of those. So what we've got to do eventually is answer these discussion questions. And I think as you go through this, you'll find that an awful lot of these you could pull from the background information. But I'd prefer that you put them into your own words, not mine. Think about how you would describe these to a friend or a lab partner or a parent or a sibling or whatever. You've got this table here, which is kind of like a different visual of this little guy here, right? So what we got to do with this guy, actually, before we answer our discussion questions, is to determine what each of these works out to be. So in order to liberate these from this sheet, I gotta pull out my skizzies. And what I'm gonna do is cut all these guys loose. And notice here the fastest way I've found to actually do this is to cut this outer edge off, or edges, I guess I should say, plural. And then once I get all these guys here cut up, then I'm going to go columns. And you just wait for the magic here. This is going to blow your minds. All right, column, column, column. Snip, snip, snip. And snip, snip, snip. I'm going to take all these bad boys and line them up like a so. And then I'm going to go boop, 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 boop. So I got all these examples, right? And now I got to pull them out and figure what the heck do they go under. So like if my first example was this one, iced tea with lemon. So I like iced tea. I like lemon. If I had an iced tea with a lemon in it, could I physically separate that stuff? Yeah, right? I mean, you know, I've got tea with some ice cubes and some lemons. Cash, I don't like lemons. Okay, Cash, it's too cold. Get those ice cubes out of there. Okay, so how would I do that? I could physically separate those. If I'm looking at a glass of iced tea, I know I can physically separate those. So it's got to go somewhere over here in the mixtures, right? Because I can physically separate them. Then the question is, okay, well, is it so evenly distributed in my iced tea with lemon that I can't tell a difference, or every single sip would be the exact same? No, right? We just said you could pull the lemon out or the ice. So that means that this guy would have to go, whoop, over to heterogeneous. And what I need you to do is work your way through all these examples. Some are pretty straightforward, some are pretty tricky. And once you've got all of them categorized into what type of matter you think it is, if you have some confusion or you just need some reassurance, let me know. And then once this is good, you can answer the discussion questions. So I'll need the discussion questions and that graph finished from you. As always, if you need help, please let me know. Until we meet again, see you later.